बेटा बहन भी बनाता हूँ, 2 मिनट रुक बस कर जा.
Grab the pencil, grab the eraser, grab the scale and grab the notebook, because now, ladies and gentlemen, the most beautiful, lovely, darling chapter is gonna start. And that chapter, I will say it is a chapter. Why? Because this whole idea is vast. And that's my emission spectral lines. Let's see how fast we can do this. Okay, so basically in the energy level diagram, you know the electromagnetic spectrum. We have UV rays, we have visible light, and then we have that infrared. Okay, now let's have a look at the energy level diagram. First, oh my dear God, what is this? These horizontal lines represent the energy of the orbit. Please remember, energy level of orbit or energy of the electron is one and the same. So, let me name these as orbit numbers. Okay, those orbit numbers are given on my right hand side as N1, N2, N3, so on and so forth. Then, similarly, for these orbits, we have specific value of total energy, which will be given on my other side. And the other side is E1 is equal to so, and I'm sure you must have learned all these formulas. Please ensure that whenever you are doing this, pause this video and keep on drawing along with me. You will enjoy. Okay? And go step by step. Now, as we go up, the gap goes on decreasing. Reason is very simple. Let's say the orbit is infinite. Practically imagine what infinity is. So that means if I want to excite an electron will never go to infinity. That means we will never get iron. Atom can never become iron. Is it possible? No. But according to E is equal to E1 upon N square, E is inversely proportional to N square. That's why when you go up, the gap goes on decreasing. Here it is infinity. Here, infinity. Can you excite the electron there? Yes. So can you make atom and iron? Yes. So let's see, let's understand. When electron jumps on the first orbit, we get radiations which belong to UV rays. So let's have a look. So in this entire scene, we can see from 2 to 1, 3 to 1, 4 to 1, 5 to 1, etc. All these lines, okay, they are formed or they were given by the idea of Lyman. That's why they were called as Lyman series. And they will form the region of UV rays. Then, when the electron jumps to the second orbit, that's what Balmer saw. And what he saw was, the following were the lines. The lines were H alpha, H beta, H gamma, H delta, and you could see. That means this entire thing belongs to the visible light. That's called Balmer series. When they jump on the third orbit, we get another series by another chap. That's called Bastian. And this entire series lies there, infrared. Wow, such a simple thing. UV, visible, infra. Now let's see. Visible means Vibgyor. More than violet of V means ultraviolet. Inferior to red, infrared. That's why in this entire spectrum, first you will find is the UV rays, then visible light, then infrared. Then suppose if they jump on 4, then what? Then another series will come. That was given by bracket. So that's called bracket series. Now this bracket series won't be under microwaves. Sorry, it will be near to infrared. And if they jump on 5, you will get something called as P-Fund series, which will be far away from infrared. So that's the whole idea. But please remember few more pointers. Let's have a look at the shortest wavelength. Shortest wavelength means the longest line. Why? Lesser the wavelength, more the frequency. Both are inversely proportional. More the frequency, more the energy. So if you are looking forward for an energy which is high, look at the last line. It jumps from infinity to 1. So it has the shortest wavelength. Now, if you ask me in Lyman series, which is the line with the longest wavelength? Longest wavelength, that means lambda is high. If lambda is high, the F will be low. F is low, energy is low. Energy is low, tingo. The tingo line is from 2 to 1. And if you talk about the entire spectrum, the tingo line will be the P-Fund ka first line. Okay, so in the entire spectrum, answer this. Which line has the highest frequency? Lyman last line. Which line has the lowest frequency? P-Fund first line. Which line has the highest wavelength? P-Fund first line. Which line has the lowest wavelength? Lyman last line. That's the whole idea. So now, dear students, let's recall the entire table. When final orbit is 1, initial orbit came to 2, 3, 4, that's Lyman series. And once you get Lyman series, the region will be UV rays. So for P is equal to 2, N is equal to 3, 4, 5, 6, it is a Balmer series and a visible light. P is equal to 3, N is equal to 4, 5, 6. It is called as Paschen series, infrared, so on and so forth. Come on, let me not sing again. P is equal to 4, you will get what? Bracket series. And bracket series means it is near to infrared. Okay? And when P is equal to 5, you will get something called as P1 series, which is far away from the infrared. This small, simple table will give you the whole idea. Clear? Now let's come towards the, oh wow, it's a big atom. The whole lines which we show in the horizontal pattern, now I have put up in the atomic form. Same to same thing. Okay? And let me derive this formula. 1 by lambda is equal to R. Now, is it proved? Yes. Is it applicable? Yes. So in your exam, if they ask you Lyman series, so in that formula, replace P with 1. So it is 1 by 1 square minus 1 by n square. And then n2 can be 2, 3, 4, 5, 6. Similarly for Balmer, similarly for Paschen, similarly for bracket, similarly for P fund. So this is the entire idea of hydrogen spectrum, dear students. Practice the whole diagram, not once, twice and thrice. Solve the MCQs and then you will see the beauty. You will start playing with all these formulas. And we'll see you very soon with my MCQs and with my numericals in my next module. See you.